Have you ever opened a controller cabinet and found a whole colony of ants or corrosion on the circuit board? Those small issues can cause big electrical problems and shorten the life of irrigation components. In this section, we'll learn how to properly clean and adjust the system controls and sensors that keep irrigation systems running smoothly. I'm Dr. DeBusk, and in this lesson, you'll learn how to identify which controls require routine cleaning and which do not, safely remove debris and seal entry points that invite insects or moisture, adjust controllers, reset power devices like GFCIs and circuit breakers, and verify sensor accuracy. By the end, you'll know how to maintain both the hardware and programming aspects of irrigation control systems to prevent damage and improve reliability. Controllers can attract more than just water. They can become home to ants, wasps, roaches, or even small rodents. These pests can corrode circuit boards, chew through wiring, and create safety hazards for anyone opening the cabinet. Even moisture from condensation can shorten the lifespan of the electronics inside, so keeping the cabinet clean and sealed is essential. After clearing out debris or pests, seal every entry point that allowed them in. Start with the conduit connections. These should be tightly attached with the correct fittings. Then check for small openings around rain sensor or pump relay wires and seal them from the inside of the cabinet. Finally, look at the power wire entry. Older installations often use Romex connectors that leave gaps, while newer models come with sealed or compression-style pigtails that keep moisture and insects out. A quick technician's note: never throw ant bait or chlorine tablets inside the cabinet. The fumes are caustic and can damage the electrical components. Only use deterrents specifically labeled as safe for electrical equipment. Adjustments to a controller are usually simple. They're often done as part of a maintenance visit. Most of the time, we're correcting small programming errors that happen after power loss or dead backup batteries. Start by checking that the current time and date are correct. Power interruptions or daylight saving changes can easily throw them off. Then review the watering days. These can reset or get deleted after an outage, which matters especially in areas with strict watering restrictions. Next, check the start times to be sure irrigation begins and ends with the local approved hours. If these are wrong, the system may run at the wrong time of day or even violate local codes. Always refer to the manufacturer's user manual for the exact steps. Anything beyond basic time, date, or day adjustments should be left to someone with proper training. Controllers sometimes lose power after storms, surges, or outages, and the display can be misleading. Even if the screen looks normal, it might just be running on backup battery. Look for icons or a no AC message indicating there's no incoming power. If the controller is plugged into a GFCI outlet, check whether the reset button has popped out. Push it back in. If it stays in, power is restored. Some models show red or green lights to indicate status. If it won't reset, check the outlet with the smaller test button or check for other dead outlets on the same line. If the issue isn't at the outlet, inspect the circuit breaker. A trip breaker sits in the middle position. To reset it safely, move it fully to off, then back to on. If it doesn't hold, the breaker may be faulty and needs replacement by a licensed electrician. One last tip: if the display is completely blank, you might have two problems: no power from the outlet and a dead backup battery. In that case, verify input voltage and transformer output before assuming the controller is damaged. Sensors need regular maintenance to stay accurate. Dirt, pollen, bird droppings, and debris can block the sensing elements and cause incorrect readings or failures. Only certain sensors require cleaning, mainly solar, rain, wind, and rain gauge sensors. Soil moisture and flow sensors are sealed or buried, so they don't need routine maintenance. To clean a solar sensor, locate the domed cover on top of the weather sensor and gently wipe it with a damp, soft cloth. If needed, a mild dish soap can remove stubborn dirt. Once it's clean, verify that it's still communicating with the controller or interface according to the owner's manual. For a rain sensor, remove leaves, moss, or other debris from the top and side vents so the discs can get wet and dry properly. If the discs are dirty or degraded, replace them instead of trying to clean them. For a rain gauge or wind sensor, remove any blockage that prevents rainfall entry or stops the wind cups from spinning. Sometimes you'll need to take out the small screen inside the gauge to clear it completely. Keeping sensors clean ensures that the system operates efficiently and responds correctly to environmental changes. For analog rain sensors, adjustments are hands-on and mechanical. First, check that the sensor is mounted straight. If it's tilted, it won't read rainfall correctly. Then look for the rotating cap at the top of the sensor, usually marked with fractions. Turning the cap to a lower number means the system will shut off after less rainfall. Turning it to a higher number requires more rain before irrigation stops. Some wireless sensors allow rainfall adjustments at the receiver instead of the cap, but the concept is the same. You can also modify how long it takes for irrigation to resume by adjusting the side vents. These control how fast the discs dry out after a storm. A quick technician's note: many models have a second smaller disc stack that shuts irrigation off immediately when it first detects rain. Only the larger stack determines how long it stays off and should be adjusted. Digital rain sensors use a display screen instead of manual dials. To adjust them, navigate to the rainfall settings screen and choose the amount of rain that triggers shutoff. Setting a lower rainfall value means the controller will suspend irrigation sooner, while a higher value requires more rain before it stops watering. Next, adjust the delay time. That's how long the system stays off before returning to automatic operation. Most sensors default to 48 hours, but you can customize this to match site conditions. Always save your settings before exiting the menu. And just like with analog sensors, make sure the sensor location hasn't changed over time. If new trees or structures block rainfall or sunlight, the sensor may need to be relocated to maintain accuracy. In this section, we focused on maintaining the controls and sensors that serve as the brain and eyes of the irrigation system. The key is prevention, keeping controllers clean, sealed, and pest-free to protect delicate circuitry. Always verify the controller's time, date, and watering schedule, especially after power loss. When you see a no AC icon or a blank display, check the GFCI or breaker safely before assuming the controller has failed. Clean exposed sensors regularly, especially solar domes, rain vents, and wind cups. Replace discs when needed instead of trying to clean them. Finally, adjust rain sensors so they respond accurately to rainfall and dry out timing, whether analog or digital. And remember, as the landscape grows, sensors may need to be relocated to keep readings accurate. Consistent cleaning and simple adjustments extend equipment life and ensure irrigation systems run efficiently year after year.